Good morning. This is your stats sensei, Mr. Spensei, and this is Death Packet Unit 3B, Probability Distributions, and this will be problems 21 through 30. In the United States, 75% of adults wear glasses or contact lenses, so P equals 0.75. In a random sample or group of 10, so N is 10, the fact that I have a group lets me know I'm probably working with a binomial. Which of the following is closest to the probability that fewer than 8 of the adults wear glasses or contact lenses? All right, so remember it's a binomial, so it could start at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fewer than 8. That means I'm looking through for 0 through 7. All right, I have multiple values, which means I'm going to need to do the summation. So I'm going to need to do the summation of n choose x, p to the x times 1 minus p to the n minus x. All right. And we know this, and we know that. This is my low value. This is my high value. So here we go. Calculator. Press math. Drop down to summation. Press X. Low value was 1. High value we had was 7. Second vars, this is a binomial. So we need the binomial PDF. Trials, we had 10, N was 10. Our p-value was 0.75, 3/4. Our x value, anytime we work with summation, we just use x. And we get 0.4744. So our best answer choice is C. At a sporting event, cheerleaders will throw 50 bundled t-shirts into the crowd. The t-shirt sizes consist of 10 small, 15 medium, and the remaining are either large or extra large. Suppose Anna catches a t-shirt. What is the probability she'll catch a shirt that is not small? Well, if 10 are small, that means 50 minus 10 equals 40. Those are not small. All right. And the probability that she would get that, the probability would be 40 over 50, which is 0.80. All right. So in this case, we know the P is 0.80. We have 50 shirts thrown. So we have a sample of that. What is the probability that you'll catch a shirt that's not small? Um, I'm gonna have to pause this for a moment because I got to think. This one I'm gonna have to think about. Sorry about that. All right, so there are 50 shirts. So basically, my sample size is 50, and they want to know the probability she catches one that's not small. We already said that 40 were not small, so 50 choose 40, and we're only looking at catching one. So 50 choose 40, and our p-value is 0.80. I don't like this problem. I'm gonna pause this again. All right. So even if she caught all the shirts, I'm sure made this difficult. This is actually a very easy problem. I just made it was making it difficult in my head. 80% of these shirts are not small, so there's an 80% chance that she would catch a shirt that's not small. All right. That's the probability is 80%. Sorry about that. Suppose that 80% of a jurors come to a just decision, and a jury is 6 people. What's the probability that more than half come to a just decision? Suppose 80% come to a just decision, more than half, and a jury is 6. So 1, 2, 3, 4, 5, 6. So more than half. This one ends up being a bit of a problem because the question is what's more than half? More than half, that's half. If three, so more than half would have to be 5 and 6. So what's the probability of having 5 or 6? Or four, excuse me, 4, 5, or 6. 1, 2, 3, 4, 5, 6. So more than three. So I have to have more than three, which would be 4, 5, and 6. And the probability P is 0.80. N in this case is 6. We're looking for a summation because we have, and this is a binomial because we have a fixed number of trials. So this is a binomial, but it's a summation. All right. So if I do this correctly, and I sure hope I am, we'll know in a moment. I'm going to press math, take the summation, X. The smallest value we have is 4. That's what we circled, was 4. The highest value is 6. This is the binomial probability. Oops. Second vars, binomial PDF. Trials of 6. Probability is 0.8. And X, because it's anytime you use a summation, it's X. And we get 0.90112. Once again, the hard part on this one, in my opinion, is going 1, 2, 3, 4, 5, 6. Half is midway. So more than half would be 4, 5, and 6. And this is my low value. That's my high value. And if I were to run this one more time, I would go math, scroll down, summation, X. Low value was 4. High value was 6. Second vars, binomial, PDF, 6.8x, boom, got it. All right, number 24. According to 2015 census data, 42.7% of Colorado residents were born in Colorado. So point P equals 0.427. If a sample of 250 Colorado residents is selected at random, what's the standard deviation of the number who were born? So in this case, we happen to have a sample size. We have a group. So that tells me we're working with a binomial. They're asking for the standard deviation. That formula is n times p times 1 minus p, which in this case is 250 times 0.427 times 1 minus 0.427. So let's do that. 250 times 0.427 parenthesis 1 minus 0.427 close parenthesis. And I need to raise that to the half power to take the square root of it. So I end up with 7.82. So 24 is B. Moving right along. 25, an inspection procedure at a manufacturing plant involves picking 3 items at random and then accepting the whole lot if at least 2 of the 3 are in perfect condition. If in reality 84% of the lot are perfect, so our probability is 0.84. What's the probability that the lot will be accepted? So N is 3. Okay, so we can have 0 that are good, 1 that are good, 2 that are good, or 3 that are good. But what we're interested in is having at least 2 of the 3 in perfect condition. So that's what we're interested in. We have multiple values. So this is going to be a binomial because we have n of a group size. So it's a binomial because of the group size, but because of multiple values, this means it's going to be a summation. So with the summation, I'm going to go math, summation. The low value I circled, well, X. The low value I circled is 2. Oops. I'm just going to quit that, clear that, start over. Math, summation. X equals 2. The high value is 3. Second vars, binomial PDF. Trials, we have 3 trials. The probability, they said that the P is 0.84. And anytime we have a summation, we're going to use just an X. So we end up with 0.9313. Our best answer choice is E. Number 26. According to a one poll, only 8% of the public say that they trust in Congress. In a simple random 10 people, but we have a sample size of 10, what's the probability that at least one trusts Congress? So 8% trust Congress. We have a P equals 0.08. And we have a random sample of 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of these, this makes up at least one. Because I have a sample size of 10, this makes this a binomial. Multiple values is a summation. 1 is my low value, 10 is my high value. So with that going like that, stat, math, summation, X, low value is 1, high value is 10. And second vars, binomial PDF. Trials is 10. That's our sample size. That's what we said. Our probability is 0.08. Because it's a summation, we need to have an X for the X value. And when we do that, we get 0.566. So 26 is D. 27. Which of the following is incorrect? The histogram of binomial with 0.5 is always symmetric no matter what the value of n, the number of trials. Yes, this is true. That is a true statement. It'll look like this. The histogram of binomial with 0.9 is skewed to the right. No, 0.9 is actually skewed to the left. All right. So 0.9 is skewed to the left. 0.1 would be skewed to the right. Okay. 28. It's estimated that 20% of all drivers do not signal when they're changing lanes. P equals 0.20. What's the probability that at least one does not signal when changing lanes? So we, when we have a group of 4. All right, so n is 4. This tells me because I have a group, this is a binomial. So I have 0, 1, 2, 3, 4. And in this case, at least one. Please remember, anytime you have least, it may be a 1 minus situation. So we're doing 1 minus the probability of 0. Now this gets complicated because we're not able to actually show our work the way we want to. So 1 minus the probability of having 0. Because we're not going to find our answer choices there. Because we're going to want 1 minus something else. We're going to want 1 minus this. So, or normally we'd go the probability of this plus the probability of this plus the probability of that plus the probability of this. But we're going to have to do 1 minus the probability of 0. So remember, the binomial has n choose x, p to the x, 1 minus p to the x. That's what the binomial looks like. And in this case, we're going to go, okay, 1 minus, and we'll put a bracket there, and we're going to go n choose 0. What is that? 4 choose 0. 4 choose 0, and then we're going to have 0.2 to the 0, and then we're going to have 1 minus 0.2, 0.8. 4 minus 0 is 4. So the one that has 0.8 to the 4th is this one. That's the answer, because this part right here, that becomes 1, and this becomes 1. So this is 0.8 to the 4th. Our best answer choice is B. That's a tough question. Number 29. According to one poll, 12% of the public favor legalizing drugs. In a simple random sample of 6, so, okay, N equals 6. We have a sample size, we have a probability that's fixed. This makes this a binomial distribution. What's the probability that at least one favors legalization? So once again, we're going to be looking for one minus the probability of zero because we have 0, 1, 2, 3, 4, 5, 6, our number line. We're actually interested. This is what we're interested in. So we can do one minus the probability of zero. And the reason I know I'm looking for that is because of the way they have these set up. So what do I have? 1 minus, and remember our formula. Our formula is n choose x, p to the x, 1 minus p to the n minus x. So 1 minus that. Well, 1 minus n choose x. Well, we have a group of 6, but we're going to choose 0. 1 minus 6, choose 0. 0.12 to the 0. Oh, this part's going to go to 1. And then 1 minus 0.12 to the 6 minus 0 is 6. So what am I looking for is the 0.88. Well, the one with 0.88 to the 6th power, because 1 minus 12 is that's 0.88 to the 6th power. That's that one. Answer choice is C. Number 30. You win a game if you flip a coin with heads coming up exactly 50% of the time. Would you rather flip it 10 times or 100 times? A lot of people have trouble with this problem. So here's what I would say do. All right. Um, it has to be exactly 50%. So let's do this as a binomial. 50% of 10 is 5. So this would be a 10, choose 5. Or 50% of 100 would be 100, choose 50. We're going to do those as both as binomials. You know what? I'll go ahead and write this out. Probability of coming up heads is 0.5. So this is 0.5 to the 5th. This is 1 minus 0.5 to the 5th. This is 100. This is 0.5 to the 50th. And this is 1 minus 0.5 to the 50th. Well, when I do these problems, we're going to go second vars, binomial 50, and it's only a singular. Oh, that's the other thing I should say. It's only a singular value. I'm just going to do this one. If I go make my number line, the middle number is 5. So it has that I only circled one value. Since I only circled one value, this means I just have to do a PDF. And I know it's a binomial because I have a specific number of trials and a probability. So let's do that. We're going to do it twice. Second vars, binomial PDF. Trials is 10, P is 0.5. X value, we have to have exactly 50%, so 5. So that's 0.246. So it's for 10 times equals 0.246. Oh, and then 100 times equals, let's do that one. So second vars, binomial PDF, make that 100, 0.5. X value has to be 50% or 5. So 0.0795. I'd rather flip it fewer times. So 0.046 is greater than 0.079. That's what I prefer. Suppose we have a random variable x where the values k equals 0 through 12. The associated probabilities are blank and blank. What is the mean of x? Well, they gave me this. All right. The fact that they gave me this equation means I have my probability. N is 12. That's my sample size. P is 0.34. The expected value or the mean is for binomials NP. So in this case, 12 times 0.34 is 4.08. So my best answer choice is C. Oh, I was supposed to already stop. All right. Appreciate you watching, and I hope to see you on the next one. Thank you.